Right, we're going to get started. So thanks for showing up. The first session of the day, and I'm going to run the rest of your day. So it's going to be 40 minutes of just terror. So congratulations for showing up to this, voluntarily, might I add. So I'm going to show that URL at the top right-hand side of the slide several times throughout this, and we'll end the session with that URL. This talk that I do is usually ranges from a 90-minute to a 2-hour talk, and I have greatly consolidated it for a 40-minute time slot together because we got quite a bit of demo. So the full presentation, which you'll absolutely want to have in your hands, because it shows if you want to programmatically build these clouds through APIs, there's references for APIs. If you want to programmatically build this through CloudFormation, Google Deployment Manager, Azure Resource Manager, those types of things, there's also references for all of that. If you want to build it by hand, I show you the CLI for every public cloud provider in addition to stuff for OpenStack to build all about what we're going to talk about in here today. So you definitely want to grab those full slides. So our topic today is multi-cloud networking, and we're going to make an attempt to link some on-prem clouds, such as OpenStack, into multiple public clouds. My name is Shannon McFarland. I work in the Cloud CTO group at Cisco, and I focus on multi-cloud networking, containers, Istio, those types of things are what I do currently. The best way to reach me, outside of tripping me in the hallway here, is grab my Twitter handle, IPv6. You can kind of get a hint of what I've done for a good chunk of my career. It has something to do with the next generation protocol. But that's my Twitter handle, and that's the best way to reach me. So just a quick blurb on the agenda. So under the multi-cloud umbrella, which seems to be a very common term that we're using these days across the entire industry, we are only talking about one aspect of multi-cloud. So we're not talking about compliance and API gateways and how do you move workloads and workload portability, and all of those things are not our topic today. We're talking about multi-cloud networking, and we're going to talk first about what it traditionally looks like when we're building a hybrid cloud connection, a single on-prem environment to a single public cloud environment. And then we're going to start bolting more cloud environments into that. There are many transport mechanisms that are available to you when you want to link all of these places together. We're going to talk about just one of them in here today. In the larger deck, I show you references on multiple other places where you can go and grab information. So if you're wanting to extend your public clouds through MPLS in a secure way, you can run 2547 over DMVPN. If you want to do co-location with Direct Connect or Express Route or Interconnect from a public cloud provider, you can do that through VLAN extensions, OTV, L2TP v3, lots of different mechanisms that you have available. In our 40-minute time slot today, we're going to talk about just one, dynamic Multipoint VPN, and we're going to spend a little bit of time on looking what that transport looks like. But in your actual presentation that you guys can grab in this URL right up here, you can get a lot more information about what DMVPN is. How do you get it? Can you get an open source version of it versus a vendor supported version of it? What are the components and how it's made up? And we're going to briefly touch on it, and then we're going to get actually kind of into the demonstration side to show how it works. Again, I provide you inside the larger deck a bunch of stuff around the cloud automation templates. So if you are running into an AWS or a Google Cloud Platform or Azure environment, and you want to see how you can build VPCs and subnets and routes and security groups and virtual appliances and the configurations that go on those virtual appliances all through a single template. Myself and a guy that I work with, Matthew Montgomery, we have kind of assembled a suite of example templates that you can use and repurpose in your environment to actually bring these up in a single template. Also, later this week, some colleagues that I work with are doing an extension of this talk focused on the open source version of DMVPN. So DMVPN was a Cisco innovation a long time ago, and it has actually been open sourced in the world of Open NHRP, or Next Hop Resolution Protocol. So they'll actually be giving a talk later this week that kind of follows on to what we're talking about here today. So we're going to do a quick level set on what we mean by multi-cloud networking. So first, when we refer to hybrid cloud networking, it is just as simple as wanting to extend on-prem workloads, cloud or not cloud, into a single public cloud. That's pretty much as basic as it gets. When we refer to multi-cloud networking, we are referring to that same thing, but just to multiple public clouds or even between public clouds themselves. And we'll topologically look at this pretty soon. The thing that we want to focus on when we're building these multi-cloud environments is that we want to create some level of consistency between what we do between one peering relationship and all of the other peering relationships. And I'll explain to you later how that's not always possible. Usually through mergers and acquisitions kind of muddy that up. But really what we're wanting to do is we're wanting to try to create an identical policy and an identical implementation model that spans each one of these relationships that we have between our on-prem and multiple public clouds. So we want to glue together some common network transports, such as our encryption policies, such as our routing policies, high availability. We want to gravitate towards a singular tunneling methodology that we can just kind of cookie cutter each one of these connections, and if we need to rinse and repeat them, we know that we have a consistent template to build from. So some of the common ways that we can establish connectivity between our on-prem OpenStack environments and a particular public cloud is we can utilize over-the-top native VPN services. We'll see this in a picture in just a minute. We can also leverage dropping an open source or a commercial product inside the public cloud to help us with that. We'll talk about that as well. And then you can also have a co-location agreement with these public clouds to kind of extend some of your enterprise or on-prem functionality into it. And so we'll take a look at some of these from a picture. So when we want to begin this relationship with extending our workloads or extending our network transport to the outside to another public cloud, we do so through one of a couple of common mechanisms. The first one at the top is what we just call Sitetosite IPSec. This is where we are using a native cloud provider. Google is shown here, but AWS, Azure, and many other cloud providers offer this service, where we're just simply setting up a point-to-point IPSec connection to our on-prem environment. And we start to exchange some either static or BGP routing relationships, and voila, you now have a hybrid cloud. This is a fantastic way to get started because it is incredibly simple to do. Matter of fact, there's in the presentation that I show you the exact commands for each of the public clouds to do this. And you can bring that VPN up to your on-site in 30 seconds. I mean, it is incredibly fast to do this. But we'll talk about later how this becomes kind of a limiting factor. The other alternative that you have to building this simple IPsec VPN environment is to do a co-location arrangement. So direct connect with AWS, interconnect with Google, and ExpressRoute through Azure are examples of that, where you're basically stretching a very long line between your environment through a co-location facility into that public cloud provider. And so there's a lot of advantages to that, and in your slides, the full version of the slides, you can see what some of those pros and cons are between these two. The discussion we're going to focus on today is making this type of topology usable for us when we're trying to build a multi-cloud transport. So when we step into what this looks like from a Cisco or from a OpenStack environment, we have a variety of topology options. So the first one is the most prevalent. So I've been at Cisco over 18 years, so I spend a lot of time with customers, and when we look at these types of transports, this absolutely wins by the vast majority. And this is where I'm an OpenStack down here, and I am utterly clueless in how I connect to the rest of the world. It is handled by another operations team. These relationships with public cloud providers, that peering relationship is handled. And basically my traffic follows default routing and internal routing within my data center and eventually finds its way to a dedicated tier in my network that we refer to commonly as the internet edge, where I am using physical or virtual appliances to connect to the co-location relationship or the VPN relationship itself. So there's really not much going on in the OpenStack awareness. The second one is another very popular methodology, and that is where I actually drop a virtual router inside of OpenStack, and it is responsible for my VPN, my routing, firewall services, those types of things. And again, there's many vendors that provide a virtual router that can go into OpenStack, and there's also lots of ways of doing this just on your own, building Linux and OpenVPN and Bird and Quagga and all kinds of ways that you can establish this type of connectivity. And then the third, and probably the least most used, because I've worked with the VPN as a service since the inception of VPN as a service, and I still can probably count on one hand the number of people that have ever actually deployed it at any scale in the real world. But that is absolutely an option for you to have the integrated VPN as a service within OpenStack built inside of your cloud environment itself. And we'll talk a little bit more about how that is totally applicable, but how that also does not scale. And so we need to look at some better options for establishing this connectivity. So when we want to start out in this multi-cloud environment, we begin with a very simple environment. So we want to see what we can learn by just bringing up a simple native VPN service. So we are using the native VPN service from the public cloud provider, establishing IPSec into a physical or virtual router or firewall inside of our environment. We establish either static routing or BGP routing. That's what all of the public cloud providers support. And now we have routing exchanging, and we have direct connectivity between those two. Pretty simple. Then we start to add more stuff. We are adding on a per tenant or a per cloud or a per site basis. We just start adding more and more of these point-to-point IPsec relationships in our environment, and we get the routing moving, and everything looks pretty good. So now somebody comes and says, okay, because of this merger and acquisition, or because of cloud provider high availability, we're adding more clouds into this mix. Okay, so this is very, very common, is that you are with AWS as an example, and you acquire or are acquired by a company that is with Google or Azure. And you're not getting rid of either one of them, you're adding one to the mix, okay? And so this becomes a very, very common situation of, do I go ahead and start doing native VPN connectivity from my on-prem private cloud environment to more and more and more sites and more regions and more cloud providers in my environment? So the challenge that we start to get into is when we want to also start to link these public cloud providers together directly. Why would I go all the way here when I actually want some sort of middleware application to talk to some sort of telemetry application here? I will establish connectivity here. So we can see as the number of these connections grow, and by the way, they're all pre-shared keys. So we're doing synced passwords on both sides when we're dealing with native VPN services with a public cloud provider. We can't do PKI type of behavior to rotate those keys, et cetera. They are all pre-shared keys. So when we start to scale these, or we change them frequently. We build them for a given project, we tear them down when the project's done, and we go to rinse and repeat this all the time. This becomes a very, very ugly situation. In the WAN world, we call this the WAN mesh problem, right? Because I want high availability connectivity between all of these sites, but doing them from a configuration and from a key management structure, this becomes a pretty ugly scenario. So a perfect example of this is when we want to do this with OpenStack VPN as a service. So in this configuration, I mean, we can see I'm not walking through the config because I don't really care about the config, but I'm walking through the complexity problem, right? I'm establishing IKE policies for just this relationship. But my IKE policy between OpenStack to AWS may be a radically different IKE policy than I do to Google. Why? Because they require different types of PFS, key rotation, aging of your IPsec environment. All of those things are very cloud provider centric. So as I scale the number of these, I may have multiple policies for IKE, multiple policies for IPsec, multiple endpoints within my routing infrastructure. I may have to figure out when I run VPN endpoint groups within OpenVPN, or I'm sorry, VPN as a service, and I want to link the types of networks that are going to be sourced from my side to the destination of the cloud provider. I've got to build all of these, and Heat doesn't help you. If you want to automate this with Heat, Great, you're taking out the CLI part of this, but you're not taking out the complexity of all of the custom policies that you have to deal with from each of these sites. So this starts to move you towards the path of getting away from this kind of point-to-point IPsec WAN mesh complexity. And so some of the trigger points to kind of help you get away from that is obviously the large site-to-site designs really suck, right? Because from the configuration complexity and all of that we've already talked about. But there may be some other technical aspects that trigger me to want to do something differently. So a perfect example of this is when you need to do NAT transparency, which is an RFC. It's a standard way of detecting that you are behind network address translation and modifying my IKE and IPsec behavior to overcome that. Well, not every public cloud provider out there with their native VPN service supports NAT transparency. So if you're like most customers that deploy an entire group of hardware or virtual VPN boxes behind a tier of NAT, then you kind of can get killed with this type of model because you actually cannot establish your IPsec relationships with that native VPN service because they do not detect NAT transparency. You have to publicly address those VPN endpoints. So that's one trigger point. Another one is that you want to treat your public clouds just like another data center or just like another branch. So you want to have continuous policy that you have inside your data center or within a side of OpenStack. You want that to exist in the public cloud. You want to have your routing strategy. You're an OSPF shop or an ISIS shop. You want to have those routes appear bidirectionally inside the public cloud as well. And then finally, you want operational consistency. The way you turn these sites up and the way you tear these sites down, you want to have operational consistency regardless of the on-prem environment you're using and regardless of the public cloud provider you're using. And there's some other things that are in there, and when you grab the larger presentation that I referenced, you can kind of see what some of the other justifications are. So like I mentioned before, we have many, many options for linking these sites together. We're talking about just one of them here, okay? And so if you've got very specific technical things, we can talk in the hallway. I'm here all week, or hit me on Twitter, and we can talk about if you're wanting to do this with MPLS, or you're wanting to, extend some sort of layer 2 segmentation strategy through the cloud. We can talk about that in the colo relationships. But the one that we're talking about today is DMVPN, or Dynamic Multipoint VPN. So when we change the picture of what we looked at before, where we have an on-prem cloud, and we now want to talk to multiple public clouds, instead of using the native VPN service, we are putting some sort of virtual appliance there. I'm showing the Cisco CSR 1000V, but many vendors provide a virtual router that exists, or you can build your own. You can do this with Linux and a lot of open source tools and have a nice day. But what you're trying to do here is you're trying to, one, extend the way your network inside of this cloud looks to the way it looks in here. And we do that by extending routing policy and routing support, such as OSPF, into the public cloud. We want to extend some of our quality of service policies. We want to extend some of our network monitoring and alerting. We want to have natural NAT transparency, which DMVPN provides out of the box, etc. So by establishing a product or solution and technologies into the public cloud, we now get that operational consistency. Why? Because it looks just like a branch office to me, or it looks just like a remote data center. And so all of those things that I do inside my data center, I now have capabilities of doing in the public cloud. So let's walk through some of these scenarios graphically. So the first one we're going to look at is AWS. So inside of AWS, you can use a Cisco CSR or another vendor out of the marketplace, and we can establish this connectivity here. So what we're looking at is that we've got an OpenStack environment with a virtual machine and a private network. In this case, I'm showing provider networks, but it works, as we'll see in the demo, with L3 agents, etc. And we've got a data center infrastructure here, and we're eventually making our way to some sort of software or hardware routing or VPN component that establishes a DMVPN, which is an IPsec connection, into whatever this appliance is on the inside of the network. And then we start to build all of our routing policies and our high availability policies, etc. And it just begins to look like a traditional branch environment. And so routes on this side will begin to publish routes that exist inside of OpenStack, and we'll start to exchange routes inside of OpenStack to see what's going on inside of our VPC. We can also dynamically exchange this information. So some people start off with static, but again, in this particular case, we're actually exchanging all of these routes via OSPF. So now, the picture with Google looks very similar. Different icons, but exact same consistent topology. Again, we're trying to gain consistency in this operation. So again, this side of our cloud didn't change at all. We're just using the same environment in the OpenStack side to connect to another public cloud provider, in this particular case, Google, and we are establishing DMVPN connectivity between these two particular sites. And what's, again, the consistency is now OSPF is in my mix, and it's just another site with just another area, okay? So absolute operational consistency is what I'm trying to do. And then finally, with Azure, picture doesn't change much outside of some addressing and outside of the icons. Again, the right side doesn't change. We establish DMVPN connectivity, and we build our routing policy just like we did before. So cool. Inside of your larger slides, and again, for those of you that joined us recently, at the end there is a much larger version of this presentation that shows all of the commands and configurations that you need to do at each public cloud and on your routers, et cetera. And I'll show that towards the end. But what we now need to do is take these three independent hybrid clouds, because they're just us talking to them, and we need to start linking these things together. And this is where the magic of dynamic multipoint VPN comes in, because it gives us the ability to look at all of these public cloud sites as one domain. And we call this a DMVPN domain. And this is where I actually can treat them all like they're a single entity, even though they are discrete sites. And so one of the characteristics of DMVPN is the dynamic part. This is using NHRP, or Next Hop Resolution Protocol, to allow you to dynamically discover what we call spokes. Spoke is any endpoint that is connecting to a hub, and we designate that relationship by the configuration on each of the devices. So what's awesome about the D and dynamic here is that I can bring these on and off, and I never touch the head-end configuration. It is using multicast inside of IPSec with MGRE, or multipoint GRE, and it glues those relationships together, and it creates a dynamic database that maps the inside addressing to the publicly routable internet addressing. And it maps all of those together so that we can discover. In our demo, we'll actually take a look at how that mapping works. So cool, but this is still hybrid cloud connectivity. It's just point-to-point between each of these public clouds. Well, the beauty of DMVPN, DMVPN has a variety of phases that you can enable in it to treat it differently, whether you're running MPLS over it or you're doing some sort of high availability scheme. But one of the phases in there allows spoke-to-spoke connectivity. So this is where it becomes very powerful, because now I no longer have to go from a spoke site to the hub site to talk to another spoke site. I can do this, and I can do this without ever touching the configuration. And again, we'll see exactly how this happens. So we solve this WAN mesh configuration problem by using the dynamic multipoint aspects of the technology itself, okay? So we're going to kind of take a look now at what you need to do inside of the public clouds to finish this configuration, okay? So this is what our goal is to build this. But we're not done yet. So there are things that you need to do inside of the public cloud to enable this functionality. Why? Because the public cloud itself has routing, it has security groups, and those types of things that you've got to alter to allow this dynamic any point to any point connectivity. So the first thing you need to do is you need to go into each of your public clouds. There's a Google reference here, but in the slides I show you how to do it with AWS and how to do it with Azure, etc. But you need to go in and alter either via CLI, via API, via automation of some sort, and add the routes to the other sides that you're connecting to. The reason why we have to do this is because the public cloud itself is not doing dynamic routing, right? So it doesn't know, even though our router at that site knows how to get to these other sites, the actual static rules inside of the VPCs themselves do not know about those routes. So it's going to punch you to a default gateway on your VPC, and you're going nowhere because it has no idea how to get to these destinations. So what you would do at each of these sites is you would put the destination range of the other public cloud site and put your next hop address, which is the inside IP address of whatever your virtual router looks like. So in this case, from Google, we're pointing to our inside network at AWS, and we're pointing to our inside network at Azure. And then once the packets begin to hit your VPC default gateway, it now knows it needs to give it to the virtual router, and the virtual router has already established connectivity, and away you go. And a similar type of function you need to do on your firewall, network, or security groups. Again, I'm showing you kind of examples of how to do this statically or do it in ranges where you need to allow IPSec connectivity through your firewall rules, and et cetera. And again, in the larger deck, it walks you through a lot more detail on what some of those things look like. Again, you want to do this from automation. You do not want to be running these damn commands by hand for every route you'll ever do, right? I mean, I like doing that, but I'm sick. But you do want to run automation to do this sort of thing, and I show you some of that stuff in the scripts. So let's take a look at this from a demo perspective. Okay, so here's our demo topology. What we've got is we've got an OpenStack private cloud. I've got a virtual machine that is on a private network behind a Neutron router, and we got a floating IP address on it on the 192.168.200, and 110 is the floating IP address for that. And we have got a DMVPN environment that is built already, connecting to Azure, AWS, and GCP, and we're going to check that connectivity between each site to make sure that the hybrid cloud networking is up. And then finally, we're going to link them all together and validate that that configuration actually works, okay? So the first thing we're going to do here is we can see inside of our OpenStack environment, I've just got a single virtual machine running in there. There's the floating IP address that we're going to try to reach from inside of the other environment. Inside of AWS, I've got a single virtual router, a CSR here, and a test instance behind it. And you can see the subnet that we've got over here. This is the 172.16.2 network. That's the inside network that we're going to get to via this VPN, okay? And so that part is there. Inside of Google, we have the same thing. We've got a CSR and an inside virtual machine. And we can see that 10.0.1 is the network that we're going to try to reach inside of there. And then finally, we've got the same thing in Azure. So we've got a test virtual machine and the 10.10.1 network, and we've got our DMVPN configuration with our CSR, all right? And then let's jump over here to the terminal. So here is, let me go back in here, my SSH timed out. So we can see here that we are in this 1040 network, but we have a floating IP address that is out there that we're actually going to try to reach, okay? So the first thing we're going to do, we're going to connect into our virtual router inside of AWS. You guys see that in the back? Terminal's okay? Okay. So we just want to see that our IGP, in this case OSPF, is alive and well. So inside of our AWS CSR, we've got a route for that floating IP range that's in the public address, or in our floating IP range inside of our private cloud. And we have a next hop. That 10.1.0.2 is the on-premises ASR that we're talking to at that site. So we've got routing functionality there. So if we actually come to, oh, my connection. We'll let it time out, and I'll come do this from a Google router. My VPN in the network has been problematic. Same thing from Google. Google can get there as well. Hopefully this session is alive. It is alive. Good. Okay, so hybrid cloud networking is there. So we can come from a private network inside of Google through our VPN to a private network inside of OpenStack. And then if this didn't time out, we can see the same thing in Azure. So we can get there. Okay, that one's alive. Okay, so hybrid cloud networking is there. I'm not sure why my AWS, there it goes, it died. Okay, so we got hybrid cloud networking going on between all of these sites. Okay, that's cool, Shannon. Anyone can do that. There's no big deal. There's nothing dynamic or anything about that. So what we want to actually show now is we want to show this dynamic nature where we want to establish dynamic direct connectivity between our public clouds and another public cloud. So if we take a look at the show IP route of our Google router, we can see that via OSPF, we have all of these routes. We've got a route to Azure, we've got a route to AWS's inside network, and we've got a route to our on-prem network, okay? That's all cool. And we can see that the next hop is 10.102, which means that if I want to, without DMVPN, I am going to follow this routing path that goes all the way to my head-end environment to go all the way back across that tunnel to another public cloud environment. But one of the beauties of DMVPN is this next hop resolution. So what goes on here is that when we start to establish connectivity, let's actually find the IP address of our Azure endpoint here. So if we want to go from a workload inside of Google to a workload inside of Azure, we get there, okay? But we get there initially suboptimally. So what happens when we look at these transport types with DMVPN? What happens is it begins to send a packet. That packet arrives de-encapsulated, de-encrypted at the head-end site, and the hub says, wait a minute, you and the destination you're trying to get to are a part of the same DMVPN or NHRP network ID. And I know how to get there, so you should know how to get there. And it sends a shortcut or a redirect signal back to the sourcing router. And now what happens is when we take a look at this IP route again, we now see that we get this wacky looking indicator for our destination to Azure. And what that wacky looking indicator does is it signals a next hop override. So what that tells the system to do is if we do a show IP NHRP short, we can actually now see that the destination for Azure is Azure's own router. So this actually dynamically establishes an IPsec, OSPF, NHRP relationship with no configuration whatsoever to the head-end site. So and we can actually see that from a proof perspective. Nope, sorry, that's the wrong address. Grab this one. So what this signals is if I'm trace routing from Google to Azure, what I would normally do without DMVPN is I would go to my own local default gateway, I would go back to 10.102, which is the head-end site, to go back to Azure's router to then go to my destination. With DMVPN, I'm dynamically getting there directly, and I have established a dynamic IPsec connection from Google's router directly to Azure's router. Okay, so this is incredibly powerful. I can go hit my local gateway, go to Azure, and then end up at the destination that I really wanted to go to, to begin with. So that part of it creates that kind of that dynamic relationship that we're looking for in this particular picture. So when you're thinking about this from an application environment, I could have part of my applications running in Magnum or as virtual machines inside of OpenStack, and now I need to either from a elasticity perspective or maybe from just a specific network monitoring service, or maybe I want to use Lambdas, whatever the case might be, as an extension into the public cloud. And then in comes along either a public cloud provider merger and acquisition issue, or you want public cloud high availability, or maybe there's a service that one public cloud provider has in a region you need, you can dynamically link your workloads from OpenStack into that without ever touching the configuration. Again, in the full deck, I show you line by line every configuration detail to build this exact scenario, okay? So that's kind of what we're trying to accomplish, is the linkage of these sites with our OpenStack clouds in a dynamic way. So that kind of allows us to have that flexibility. So now, a few considerations as we start to wrap up. If you are picking that middle option that I talked to you about, where you are trying to build your virtual router inside of OpenStack and you want to establish your connectivity from there, there's a few things you need to worry about. So the first one is, on the far right back here, we've got a virtual machine, and it's normally going to follow the default gateway of our L3 agent and out the way it goes. But we need to signal either by putting host routes, don't do that, on the virtual machine to follow the destination to the public clouds that are out here off of this particular virtual router. So the best way to actually accomplish this is either through automation, or if you're a sicko like me, just do it line by line, from a configuration perspective, is do a subnet set with the host route. So what this is in our particular scenario, this is the inside range of Google's VPC. And we're setting the gateway to be the next hop of the inside of our virtual router, okay? And then you apply it to that particular subnet. And then what happens is that actually gets injected into the actual virtual machine of everything that's sitting back there. So that's one way of you enabling kind of that split tunneling model. Now, some people will actually use their virtual routers as their only L3 means to get off of their private subnet. So if you want to do that, then basically that virtual router becomes a default gateway for everything. It knows where to send you based upon its local route table. But if you're just doing straight up kind of L3 agent plus a virtual router for VPN, you do need to kind of monitor some of those from a routing perspective. Okay, so for those of you that did not get the URL for the larger presentation, this is the tiny URL that's up there, and it's substantially larger than what we had time to go over here today. So I'll leave that up as we end the session. So in summary, public cloud native IPsec VPN support is good. It's incredibly fast. It's incredibly well documented. We only talked about 3 of the many public cloud providers that have this type of functionality, but we had, didn't have that much time. It's good, but remember, it's always point-to-point. It's always pre-shared keys, and they always require different IPsec policies per public cloud. So the way AWS wants to do IPsec and timers and keys, et cetera, is not the same way Google and Azure do it. So you've got disparity in your VPN policy. DMVPN is one of the many transport types that you can have. If you have something else in mind, rock and roll. But DMVPN is incredibly powerful. We can add lots of other transport technologies to DMVPN in a very standardized way. If you're an MPLS shop, you can do RFC 2547 over DMVPN, so you can use the dynamic nature that DMVPN brings, but you're using MPLS as your transport mechanism into it. So pretty powerful. We have the goal of having multiple public cloud providers in kind of a hybrid cloud model, but when we group them all together, you may not get by with the continuity of configuration. Again, it could be a merger and acquisition situation where you've got all of your policies and your configuration templates and your automation done for your relationship with your public cloud. And now you are acquired or acquire another organization and they're already using a public cloud. Right? And it's not the one you use. So there could be absolute disparity in the way you build these networks, the way you do routing, the way you do encryption, et cetera. So the things that you need to kind of take into consideration is really your team knowledge around which public cloud they're associated with, right? If I'm an AWS guru and all of a sudden you drop Google on me, it's a completely different framework. The naming is different, the tools are different, the automation is different. So you need to kind of understand where you have and kind of take an inventory of that and then figure out what you want to do from a cross-cloud tool and automation strategy. So this tends to be one place where customers start to break the trend of using the native automation that the public cloud provider has. So this sometimes is when the team has always loved CloudFormation with AWS, but now they've got Google and Azure to deal with, and CloudFormation doesn't work there. So that begins the time, well, do I go to Terraform or something else that breaks a level of abstraction back? Terraform or whatever your tool set is can go and talk to those clouds on your behalf, but you, from a daily interface, are only working with that single tool set. So that becomes a pretty popular thing. Got to understand the network designs and the diversity of that, and we already kind of talked about that. And one thing that you definitely need to kind of understand is when you start to get into multi-region designs, because not all features and capabilities at the public cloud span every region. So that kind of begins something you need to kind of take a look at. All right? So that's it for me. We're at time. I'm going to leave this slide up so that you can get the tiny URL. I'm here all week, so if you've got any detailed questions, we'll take them outside, but I've got a couple of minutes for some short ones. Or you just want the hell out of this room, right? My God, this guy started us off with this talk. It's just going to go downhill from here. Any questions? Yes?
Customer has direct connect.
Yes.
So this thing would layer on top of that?
Yeah, so the question is, the customer has direct connect. Would this be a layer on top of this? This absolutely is. So your direct connect relationship would establish a simple L2, L3 connectivity, but it's not offering dynamic nature, and it's certainly not offering encryption. Go ahead.
Yeah, that was actually also my question as well. In your experience, do you see many people doing like IPSec on top of Direct Connect?
Oh, absolutely. Yeah. So there's very few that I know that are not running some level of encryption unless they are hopping off into their colo facility for something like storage caching, or they're doing some sort of geolocation service that Equinix or somebody is actually offering in the middle. But even then, they usually have some gear in a rack that is basically terminating the encryption, using the service in the colo facility, and reestablish encryption on the other side. So that's pretty popular, but it's not ubiquitous that everyone's running end-to-end encryption in that, but it's a predominant factor.
Okay. Yeah. And extending that, so if a customer has multiple VPCs, right, and uses Direct Connect and Direct Connect Gateway.
Yep.
Can this thing work on top of the Direct?
Absolutely. So we can do transit VPC designs, et cetera. So we can actually treat like a transit VPC, an intermediary VPC in the middle. Mm-hmm. We can actually build the cloud for that and actually hop into a colo facility and hop back into an enterprise if we want to use an intermediary, colo like storage offload or something like that. So absolutely, if you're running a transit configuration to link all of your VPCs together in a simple way, then you can actually use DMVPN in the transit devices and actually run clear directly into a VPC and still handle all the routing that we talked about.
Mm-hmm. Okay.
Cool. Excellent. All right, guys. Thanks. And I'll be around if you have any more questions. Thank you. Have a good day.